Hello everyone, this is next video on our series of motion and kinematics. And till last lecture we dealt about motion in a plane, right? What is motion in a plane? And then also the motions under constant acceleration. So this is a cross of those two. So we'll be dealing with a case where we will be dealing with motion in a plane with constant acceleration, and the topic of interest is projectile motion. Projectile motion, right? So before talking about the projectile motion, let's understand what is a projectile, right? A projectile is nothing but it is a body or an object which possess motion under the influence of gravity, right? So gravity is only responsible for its motion. So the body may be thrown upwards, it might be thrown obliquely or at some angle, but that body is called projectile, which is under the effect of gravity, and the acceleration, concerned acceleration will be acceleration due to gravity, right? Then there is a term called trajectory. Trajectory. So trajectory is the path with which this projectile moves, right? It is the path or a curve along which this projectile will execute its motion, right? That is called trajectory, right? And this net motion will be called projectile motion, right? The motion of this projectile will be called projectile motion, right? Now let's understand some terminologies for this projectile motion by drawing a diagram. So since this is a motion in a plane, we will need two axes to represent this. Let's say this is y-axis and this is x-axis, right? This is y-axis, this is x-axis. An object, let's say an object is projected from origin. Let's say from point O, an object is projected at through some initial velocity u, and this is the path of its motion. Let's say this is the path of its motion, right? This is called trajectory of its motion. So this point O from which this projectile is projected or thrown, this is called as point of projection. Point of projection, right? Now this projection has been made obliquely with respect to Earth's surface, right? At some angle, let's say some theta angle with respect to Earth's surface. This theta is called as angle of projection. Angle of projection, right? Now the projectile is projected from point O obliquely at an angle theta with an initial velocity u, and it follows this path and comes back to the surface of Earth, right? So this distance with which it covers in this horizontal direction, the distance it covers is called horizontal range, right? In this horizontal direction, the distance which with this projectile covers, this is called horizontal range, right? This is called horizontal range, right? These are some terminologies of projectile. Now again, in its journey of motion, there is a point where this projectile has attained its maximum height, right? At that point it has maximum displacement along y-axis, and this point, let's say this point, the direction, the distance from this point to this horizontal axis, this is called as maximum height, and this is the displacement or shift along y direction, and this is the point where it attains the maximum displacement or height. This is called maximum height, right? Now the time taken by projectile from its point of projection to cover this horizontal range, right? To cover this horizontal range and come back to the surface of Earth, this time, this whole time of this journey, this time is called as, the time taken to cover this will be time of flight. Time of flight, right? Now this time of flight has two segregations. The time taken by projectile to reach till the maximum height, right? The time taken by projectile from initial point of projection to reach to its maximum height, this time, let's say till this time will be called as time of ascent. Time of ascent, right? And the time taken by projectile to reach from maximum height back to the surface of Earth will be called as time of descent, right? So we will see whether these are equal or not, but as of now, the time taken by projectile to reach from initial point of projection to max height is called time of ascent, and the time taken by projectile to reach from max height back to the surface of earth is called time of descent, and the net time of this journey is called a time of flight, right? These are the terminologies used in projectile. Now we will derive, right? How can we derive what is the range it covers, how can we derive what is the time of flight, how much time it takes during its journey of motion and during its trajectory and all that, right? Now we will determine how can we derive those terminologies which we just discussed, like time of flight, max height, range and all that, and what are the values, right? So this is a projectile motion. The trajectory is given. We have initial velocity as u. The angle of projection is theta, right? So u is nothing but initial velocity. Theta is the angle of projection, right? So these are the quantities which are given to us. We don't know anything apart from this quantity, right? Now let's derive some of the inferences which we can get from this motion, right? Let's discuss some of the inferences. So first inference is, you can see that in x direction, right? In x direction, which is the horizontal direction, there is no acceleration, means there is no force and hence there is no acceleration. So you can say that velocity along x direction or horizontal is always constant, correct? Because there is no acceleration in x direction, right? Now what about y direction? In y direction we have an acceleration which is because of earth, and that is acceleration due to gravity, right? So in y direction there exists a constant or a uniform acceleration which is g, right? Which is g. So in x direction, since there is no acceleration, I can simply use distance, speed and time relation, distance equal to speed into time and all that. In y direction, since this is a case of uniform acceleration, I can use those equations of motion which we studied, right? So let's say in x direction, right? In x direction, let's identify what is velocities along all that, right? So we know use the initial velocity, but what about in x direction, right? Along x direction the initial velocity will be u cos theta. We have studied the resolution of vectors. So along x direction the velocity will be u cos theta. Along y direction the initial velocity will be u sin theta, correct? Along x direction the velocity is u cos theta, along y direction the velocity is u sin theta, correct? Now if I take any point on this trajectory, right? Let's say xy is my point. X is the displacement along x, y is the displacement along y. So if t is the time to reach to this point, so what will be x? X will be nothing but u cos theta into t. Distance equal to speed into time, there is no acceleration. This is, let's say, first. And what about y? Y is u sin theta t minus half gt square. This is displacement along y, right? This is s equal to ut plus half at square. Since this is a opposing earth is acting as opposing force, this is minus g here, right? So these two are my universal equations for projectile, and I can derive anything with these two, right? Now let's say if I am about to derive the time of flight, the time taken by this projectile to reach from, let's say, initial point of projection O to this point back on this earth surface, what is this point we need to, what is this time, the time taken to reach from O to P, right? O is the point of projection, P is the point where projectile has came back to its mean position, right? So time, see at time of flight, at when time equal to time of flight, this projectile has covered max distance in x-axis, but it has come back to 0 along y-axis. So displacement along y direction at point P is same as at point O, which is 0, correct? So if, let's say, if t is my time of flight, so y y at t is equal to 0, right? So if I use second equation of here, so if I place y as 0 and t as t, capital T, which is time of flight, it becomes half gt square, right? Again, if I solve this, tt will cancel each other, t equal to 2u sine theta by g. This is the time of flight, right? So this is the time for which object will be in its course of journey, right? So this is what is time of flight, right? So you see, at time of flight, at time equal to time of flight, this object is at point P and it has covered a distance which is maximum, or which is called R, which is R is nothing but horizontal range. So at time of flight, it has covered maximum distance along x-axis, and that distance is called horizontal range. Now let's derive what is horizontal range here, right? So we know what is the expression for time of flight, right? So if I use equation 1 gives me displacement along x. There is no acceleration along x. So if I need to calculate r, I need to replace x by r from 1. If I do from 1, r will be nothing but u cos theta, and this t becomes what? Time of flight. T becomes time of flight, right? So this becomes u cos theta into 2u sin theta by g. This becomes 2u square sin theta cos theta by g. This becomes u square 2 sin theta cos theta by g. And 2 sin theta cos theta, if you have studied trigonometric ratio of multiple angles, this becomes u square sine 2 theta by g, and range is given by u square sine 2 theta by g. So range is dependent only in my initial velocity and the angle of projection. G is my constant here, correct? So the range, the maximum displacement it will cover along x-axis is given by u square sine 2 theta by g. This r is nothing but horizontal range, right? Now let's understand one more term over here. Now we will talk about the maximum height it attains along y direction, the maximum height it reaches, right? So let's identify this in diagram. Let's call this point as the maximum height point, right? This point is the maximum height point, right? And now derive what is this the value of this maximum height. Okay, so we discussed that this projectile has acceleration only in y direction. In x direction there is no acceleration. So at every point, if you see, it will have velocity in x direction also, which is same as u cos theta at every point, right? At every point there is a velocity in x direction which is u cos theta, right? At the point of maximum height, you see the projectile is going like this. Every time it has velocities along x and y, and this is how this trajectory is made. But at point of maximum height, if you see, it touches a maximum height, there is no velocity along y direction. At this point, max point, there is no component of velocity along y. So only velocity existing at that point is along x direction, which is u cos theta. So remember, at point of maximum height, velocity along y is 0 and velocity along x is u cos theta, right? Always remember, the velocity will exist, the constant velocity will exist along x direction, which is u cos theta, right? Now let's say the point of max height, it comes at, let's say, tth time, and the y coordinate is h, and this t is my time of ascent. You know, we discussed the time taken to reach from the point of projection to max height is time of ascent. So at time of ascent it reaches the maximum height, right? Now how to identify, how to find out that time, right? So we know vy is nothing but uy in plus ayt. Here at that point velocity is 0. In y direction velocity is 0. Initial velocity along y direction is u sine theta. Acceleration is obviously minus g, and t is my time of ascent. Let's say, let's call this as ta everywhere. Ta, time of ascent. So ta becomes u sine theta by g. Ta becomes u sine theta by g. So at this amount of time, at this value of time, my projectile is at maximum height, right? So before finding what is the maximum height, just remember the time of, this is time of ascent, and time of flight what we derived was 2u sine theta by g. So time of descent will be again same, which is u sine theta by g, and you can say time of ascent equal to time of descent, right? Time of ascent equal to time of descent. So this maximum height is obviously during midway of journey. So the time taken by this projectile to reach from O to, let's say this point is Q, is same as the time taken from by the projectile to reach back from Q to P, right? So time of ascent equal to time of descent, which is u sine theta by g. Now let's find the what is the value of max height. So again, to find this height I need y value, y the coordinate of x, y axis. So from equation 2, h is nothing, y is nothing but max height, t is nothing but time of ascent minus half gta square, right? So this becomes u sine theta, time of ascent is u sine theta by g, and this becomes half g u sine theta by g whole square. If you calculate this, this becomes, this will come as u square sine square theta by 2g, which is the maximum height. So this is the max height this projectile will attain, right? Now let's summarize everything in one. Let's summarize everything in one bucket, and let's say, let's even rub this diagram, and let's understand that if there is a projectile projected with an initial velocity u at an angle theta with respect to horizontal, it covers a range of, let's say, r, it attains max height of h, and t is the time of flight. So now we should be able to appreciate all these values. So t is given by 2u sine theta by g. My range will be, horizontal range is given by u square sine 2 theta by g. My height is given by u square sine square theta by 2g. Alright, and the time taken by to reach from point of projection to max height is time of ascent, and this time is again time of descent. So time of ascent equal to time of descent, which is equal to u sine theta by g. So these are the expressions for all these components along for the projectile motion, right? So now you see all these parameters are dependent on u and theta, right? So if you see practically, like we play basketball, we play cricket ball, we can throw a stone in a river. So all those trajectories, they follows what? They follow projectile motion. And to analytically, if you see how we can attain max range, how can we attain max height, depends on our calculation of u and theta, right? This basically affects all those calculations, right? So using that, we can easily say when can we attain max values, right? Let's take one example, right? Like if my target is to cover max horizontal distance, right? If my target is to cover max horizontal distance or maximum range, what should be the angle by which I should project this projectile, right? So I know the range is given by what? U square sine 2 theta by g. U square sine 2 theta by g. U is something which is constant. Like there is a max capability of u that I can project max with this velocity. So only thing which I can play with is angle. I can change the angle of my projection. I can change by what angle I'm projecting to expect max range, right? So you know, to know the maximum of any function, we need to differentiate with respect to theta, because theta is the variable for us. So now u square g is 0, so that is again constant. So this becomes d square sine 2 theta by d theta is 0. So sine 2 theta differentiation is cos 2 theta. This will again go to 0. So cos 2 theta is 0. you know cos 90 is 0. So pi by 2, theta is nothing but pi by 4. Pi by 4 is 45 degree. So if I project this at 45 degree, I will get the max possible range when compared to all other angles if I use. But condition is my velocity should be constant in this comparison, right? My velocity should be constant in this comparison, right? So now we will talk about equation of trajectory, right? So we know when we project any object at an initial velocity u and angle theta with respect to horizontal, it follows some trajectory, some path. So we don't know what exactly is this geometry. This does not look like a circle, right? Obviously. So we need to call what is this geometry. But to know what is this geometry, we need to know that what is the relation between x and y, which is called locus. What is this locus of this geometry, right? And which is also called as equation. Equation is nothing but equality statement representing x and y. How this x and y are related to each other at every point in this trajectory is nothing but equation of trajectory, right? So let's hold any point here, right? Let's hold any point as x and y, and we already discussed the velocity along x direction is u cos theta at any point. There is no acceleration. Velocity, initial velocity along y direction is u sin theta, which is subjected to change because y direction has acceleration, which is acceleration due to gravity. So at any point, if I take at any point x comma y, x will be given by u cos theta into t, correct? X is given by u cos into t, first equation, and y will be given by u sin theta into t minus half gt square, right? Second equation. Now from first, if I take from first, time is nothing but x by u cos theta. Now I'm replacing time variable from everywhere. So if I put this t in second, so y becomes what? U sin theta into t is x by u cos theta minus half g x by u cos theta whole square. So u will cancel. This becomes x tan theta, and this becomes gx square by 2u square cos square theta. So y equal to x tan theta minus gx square by 2u square cos square theta. So you see this is of form y equal to ax plus bx square, right? Where a is tan theta and b is this constant, right? And this equation is called as equation of trajectory. Equation of trajectory. And this shape which follows this equation is called as parabola. So this trajectory of this projectile is nothing but parabolic trajectory, right? So during its motion, it follows a parabolic journey, right? So we will discuss more on this trajectory and geometry in coming classes, and we will solve numericals on this particular topic. Till then, thanks.